Hello everyone, this is Akansha Bharti studying in 8th semester ECE, Shivankeshwara College of Engineering, Bengaluru. Today's explanation is about design of inverter for PV power system under the guidance of Mr. Mukesh PD. These are the fellow groupmates, Deepthi A, Danush Reddy, Gagna G, Nagbhushan Sharma S. In this video, we'll go through introduction, literature survey, and then references. Coming up to the introduction, as energy can be harnessed directly from the sun, solar energy is one of the promising renewable resource that is used to produce electricity. The power generation of solar power PV system constantly varies in accordance with the weather condition. Hence, the inverter play a crucial role. The variation of power production can affect our grid power quality, including voltage swing, power factor change, frequency unsteadiness, boost in harmonic distortion, etc. The inverter's function is to regulate power flow among the grid sector in order to enhance the generator productivity while avoiding unexpected conflict brought on the transmission failure or generator instability. The basic voltage and current inverter are built to form the Z inverter utilize the maximum energy level renewable energy. The voltage inverter and current inverter are mostly used to energy conversion system. In most of the cases, basic inverters cannot be able to promote the source effectively. So we use Z source converter is to apply the break down the hypothetical abstraction and the restriction of basic inverter or a converter. The most efficient mode of operation is to impulse again. The mode provides minimum energy loss in the power semiconductor components and efficiency of the inverter. There are several different power inverter topologies currently available for connecting PV modules to terminal in use. The aim of project is to model the operation of single-phase current bridge inverter in MATLAB Simulink programming environment. In the output side of PV array system, the output of array firstly connected with DC to DC boost converter, then output of the converter is fed to 3-level IGBT bridge inverter for converting DC power to AC electrical power. IGBT is insulated gate bipolar transmission bridge. The output of boost converter is to control by maximum power point tracking system, which is called MPPT. There are two methods to use solar energy in electricity generation, namely solar PV and concentrated solar power CSP. CSP typically produce electricity for large-scale power plants by using mirror to concentrate sun rays. The grid serves as a storage medium supply energy to grid as long as there is sufficient sunshine. In a grid-connected system, an inverter is used to connect and synchronize a PV array to grid. Connecting the direct current electricity to grid's alternating current electricity at grid voltage level. The input side of PV array is mainly controlled by two factors. One is irradiance and other is temperature. The stepwise development in the PV inverter goes from central, then to string, then to the multi-string, and then final micro. Normally, techs are commercially available as a small modules. If a thermal difference is applied across the surface of these modules, an electrical current will flow since techs are manufactured from P and N semiconductor material. A PV is used to supply load and charge a battery bank with the appropriate MPPT. A boost converter is used to perform an MPPT and each converter is connected to load. The MPPT is basic an algorithm called slide mode. So coming up to the next, control method of the PV inverter are equally important. By adding the reserve power protection device, the voltage, the current and power of the network are detected when the load is changed. The output of inverter is adjusted by the constraint production power control mode and the power balance in the network is kept. Energy generated in these systems are not by it is delivered directly to the grid. Designed in various ways depending on the switching frequency of the semiconductor component. If the switching frequency is low, like for example 100 Hz, slow switching power electronics unit can be applied. The dynamic regulation mode of the inverter increases the flexibility and improves the quality of the power supply compared to the way that the inverter is hard excised to match the photovoltaic power and the load consumption power in the network. Coming up to the literature survey, these are the papers or the books we have referred for our presentation. So going through the first paper, which is grid connected solar photovoltaic system for covered linkways. These paper have its own drawbacks and advantage too. This published in 2022. Let's see first pros of this paper. You do not have to buy any expensive battery backup system to store any excess energy. These are the utility is this is the utility is 100% efficient battery in itself. You will not need to implement any change to your lifestyle or means of conserving energy. You will love to receive credit from the local electricity grid power for an unused energy that you have generated. Now let's go for the drawbacks of this paper. You will love receiving your credits from your local electricity grid provider for any unused energy that you have generated from the solar inverter or still feeding electricity into a damaged grid. It would risk the safety of the people repairing the faults in the network. They can't produce solar energy and reduce your power bill at night time or when there is no sunlight. Going through the next paper, which is PV based power generation and power quality improvement using SSC power consumption, which is published in 2021. The advantages of this paper is they eliminate bulky passive components such as capacitor and inductor. They can supply or absorb reactive power. The ability of offer inductive and capacitive operating modes systematically is also a benefit. When connect with a DC power source on a DC side of an SSC, they can exchange real power to power system. The drawback of this paper is SSC decrease voltage predictivity index in consumption in comparison to system without SSC. The next paper is design and performance analyzed to transformer-less Z-source inverter in PV system. It is published in year 2021. The advantages of this paper, its function as a bulk boost inverter without making use of DC-DC converter bridge due to its unique circuit topology. Provide an efficient mean of power conversion between source and load in the wide range of the electric power conversion application. Transformer-less inverter are light, compact, and cheaper than the conventional inverter. The drawbacks of this paper is behave in a boost or a bulky operation only. Thus, the optimal output voltage range is limited, either small or greater than the input voltage, vulnerable to EMI noise, and the device get damaged in either open or short circuit condition. The combined system of DC-DC boost converter and the inverter have low reliability. Going through the next paper, which is research and design of inverter applied in solar PV system connected to distribution grid, which is published in 2020. The advantages of this paper is grid connect PV system are comparatively easier to install as they do not require a battery system. The effective utilization of generated power because there are no source storage losses involved. Even though the sun doesn't always shine, and installation gives a reasonable predictability average reduction in carbon consumption. Going through the drawbacks, grid connect PV can cause issue with voltage regulation. Grid connected with PV can compromise power quality. PV's intermediate nature means rapid change in voltage. This not only wear out voltage regulator due to frequent adjusting, but also can result in voltage flicker. The next paper is multi-level transformer-less PV inverter-based real and reactive power injection for single-phase system, which is published in 2019. The advantages of this paper are transformer-less inverter are generally more efficient than conventional inverter. because they are able to avoid internal energy loss and extra component cost. Due to the absence of uh, transformerless inverter are light and compact, relatively cheaper than conventional inverter. Since transformerless inverter use electronic swing, the amount of heat and buzz produced by standard inverter is greatly reduced. The drawbacks of this paper is in conventional inverter, the DC and AC circuit is isolated. This is not in a transformerless inverter. Even though in some transformerless inverter, the current pass through the capacitor and the capacitor may not always be the reliable and actual transformer. Coming to the next paper, which is Design of Distribution PV Grid Power Constrained Production Control, which is published in 2018. The advantages and disadvantages of this paper are deploying distribution PV can reduce transmission line loss, increase grid reliance, avoid generation cost, and reduce requirements to invest in new utility generation capacity. The drawbacks are the integration of distributed PV resource into the electrical power grid presents some difficulties for management and dispatch. PV panel introduce unmanaged two-ways current flow into the grid. Because isolation is variable, the intimacy of power available from the PV panel creates uncertainties in the management of the grid. Coming up to the next paper, Modeling of Power Inverter Used in PV System, which is published in 2017. Solar energy can reduce your home's electronic bill. Solar panel have low maintenance cost. Solar energy is renewable energy source and reduce carbon emission. Solar power can get your money back through solar renewable energy credit. Coming up to the drawbacks, the high initial cost of installation panel. Solar energy storage is expensive. Solar doesn't work for energy roof type. Solar panel depends on sunlight. Coming to the next paper, simulation study of small isolated power electronics converter for PV system, which is published in 2016. The advantages of this paper is, first we'll go through the self-compliance. Isolation separates output from dangerous voltage on the input. Functional isolation is the most simple, and while providing isolation, it does not provide any protection against electric shock. Break of ground loop circuit are the sensitive to noise, can benefit from this by having their ground broken up and separate from noisy circuit that could cause problem. Floating output and level shifting. Our floating output may have one of its terminal connected to another circuit node to fix it that voltage, and can be used to shift or invert the output relative to another point in the circuit. The drawbacks of this paper are complicated design. Generation of power is difficult in power electronic system. AC to DC and AC convert operate at a low input factor under certain operating condition. Power electronics controller have low overload capacity. Power electronics converter circuit have a tendency to generate harmonic in supply system as well as in the load circuit. Coming up to the next paper, design a single stage inverter for photovoltaic system application, which is published in 2013. The advantages of this paper is controlling a real and reactive power flow is possible, less expensive to purchase, versatile, and can be transmitted long distance over two wires. Coming up to the drawbacks is that the inverter has to run at full output in order to maintain its change and may suffer from overheating if there is not enough sun available. Inverter runs at full output even there is no current coming in potential causing damage to your appliances. So in the end, we'll just go through this references. These are the papers and books which we have referred for our presentations. Thank you so much, guys.